we have f of x, which is natural log x, and the interval is between 1 and 4, and we're asked to use 4 subintervals. So after dividing that, I got here 7/4, here I got 5/2, here I got 13/4. And how do I get those? So delta x, that's our first prep always. 4 minus 1, which is 3, divided by 4. So this is 3/4, this is 3/4, this is 3/4, and this is 3/4. So after doing that, when I determine the area with left 4, I have 3/4 multiplied by f of 1 plus f of 7/4 plus f of 5/2 plus the last one, f of 13/4. And my calculations gave me 1.990. The area with the right 4 would be 3/4, but I have to start with f of 7/4 plus dot dot dot, and I finish with f of 4. My calculations 3.0306. And the area with M4, now I have to determine these midpoints. And my calculations gave me 3/8. The middle one was 17/8. The next one 23/8. And the last one 29/8. And yes, this will be posted shortly after class. And my calculations, so one more time, so this is 3/4, f of 3/8 plus f of 17/8 plus f of 23/8 plus, I'm not looking at this, I'm hoping you can see this, so f of 29/8. And my calculations, I got 2.5621. And actually, to check myself, I use the technique that we talk about in Calc 2 called integration by parts. And when I calculated it, I got exactly 2.4. The integral from 1 to 4 from natural log of x dx, I got 2.54. But we're not talking about this today in Calc 2. If you want to take it, I teach it over the summer online entirely. Okay, so other questions, anything else that you tried, anything else that you would like to work with before we continue with some properties and apply some properties in different situations? Anyone? I'm going to share my screen then. Here it is. And I would like to look at, I'm in section 5.2, and I'm looking for properties. Properties. Yes, so here's one situation. Please choose. Write as a single integral. Number 57, 58, 59.
Can we do 58?
58. Very good. Let's take a look at 58. Perfect. So 58. I'm copying it, and then I will stop sharing. The integral from 2 to 8 from f of x dx. They are giving us 7.3. And then the integral from 2 to 4 from f of x dx equals 5.9. We're asked to find 4 to 8 from f of x dx. Perfect pick. I'm going to stop sharing. Here it is. So this is our question. So I look at 2 to 4, I look at 2 to 8, and 4 to 8. So what does this really mean? Okay, so which one is the wider? So it's the integral from 2 to 8 from f of x dx, which must be the integral from 2 to 4 from f of x dx, plus the integral from 4 to 8 from f of x dx. So 2 to 4, 4 to 8. I have this, 2 to 4 is given to us as 5.9. I have this is given to us as 7.3. So obviously, this must be 7.3 minus 5.9. So the integral from 4 to 8 from f of x dx must be 7.3 minus 5.9. And is it 1.4? Correct me if I'm wrong.
Yeah, 1.4.
Perfect. Okay, I'm going to share more properties. So this is one of the properties that we kind of used last time with definite integral. With this, something like this. Okay, I would like to, we can determine these areas from the graph. That's another option. Any graph, it doesn't matter. But what I'm interested in is looking at problems like these. Okay? Use the properties of integrals. They mean the definite integral. Use the properties of definite integrals to verify the inequality, without evaluating the integrals. So for this one we can evaluate. For these two we did not learn how. I will teach you in the end of chapter 5. For this one we cannot. We are not equipped to do that. And for this one we can. So we're not going to evaluate anything. We're just going to use the properties to show that whatever the inequality is. Okay, so I'm waiting for you to choose. I just want to see what else is in this book, because it's different than my old book.
Can we do one for graph?
I'm sorry?
Can we do one for graph?
Oh, yeah. Okay. So is it 61 you want?
61.
Okay,
61.
perfect. Okay. For the function f whose graph is shown, list the following quantities in increasing order. Okay, so we have to determine them and then list them in increasing order. Good, so this is problem 61 and then 5.2. Perfect pick. So the integral from 0 to 8 from f of x dx. 0 to 8. So in order to estimate this, I have to use rectangles. This will be a positive area. This will be a negative area. I don't have the function. I cannot do anything. I can only estimate. So I'm going to use I'm thinking, so I have here 3. What do I want to use? Okay, so I'm just going to estimate from the graph. I'm not going to use the integral or rectangles. I'm just going to count. I'm going to say this is a full square, so 1, because this piece is kind of equal to that. It's not, kind of. So 1, 2, 3, roughly 4. So this is negative 4. Let's see what we have here. 1, 2, 3, 4, 5, 6, 7, 8, maybe 9, 10, 11, 12, 13, 13 and a half, maybe 14 with this. 14 minus 4, I'm going to say roughly the integral from 0 to 8 from f of x dx, I estimate it to be 10. Okay, now they want the integral from 0 to 3. The integral from 0 to 3, I estimated it to be negative 4. Then the integral from 3 to 8, we already did that. So 3 to 8 from f of x dx, I said approximately 14. 3 to 8. Okay, 4 to 8. 4 to 8. So I'm going to subtract 1. So I'm going to say roughly 13. 4 to 8, f of x dx equals 13. F prime of 1. So here's 1. Now I have to draw a tangent. So obviously this is 0 here. A tangent at 1 will be negative rise 1 and run 1.2. So negative 1 over 1.2. So f prime of 1, negative 1 over 1.2 roughly. Okay, so now we just have, it says list these quantities in increasing order. So I would say when I divide 1 by 1.2, what do I get? 0.8. So this is approximately negative 0.83. Okay, so I'm going to say in ascending order, sorry. That's what they want, right? I think I read it. Increasing, yeah. Okay. Good, so in increasing order, I will say that this is number 1. Let me use a different color. I'm going to say that this is number 1. I'm going to say that this is number 2. I'm going to say that this is number 3, this is number 4, and this is number 5. So this problem really, I would not estimate using rectangles and just approximate. They are not close. They're just these two, but obviously the area under this, 3 to 8, is definitely more than 4 to 8. No question there. Everything else is not even close, doesn't even get close. Okay, so I don't have to do anything else. Okay, so I still would like to us to choose from these properties. So I like to start with maybe 68, if that's okay, or you want to choose something else.
Yeah, we do 68 and then afterwards we do 67.
Okay, 67 and 68. Okay, so for 68 we have, let's start with 67. Let me copy 67 first. So we have 2 less than or equal to the integral from negative 1 to 1 from the square of 1 plus x squared dx. And they say we have to show that this integral is a number between this and this. We cannot calculate this exactly. We just have to show that it's a number between this and this. There is a property that we looked at last time, and the property is something like this. So this is the property that we are trying to use. But only if, oh, of course, I'm sorry, b minus a. But the starting point is to show that the function is between these two numbers. And then we can integrate to get that. So this is the property that we want to look at. So what is my starting point? My starting point has to be here. What does this say to me? Can anyone say? Identify what that tells us?